Hi, this is Rich B and AZ, and this part is about the mathematical, well, not really mathematical, geometrical proof of how you can get one of these wheels to balance on a steel ball. It does work, and I've done several different pilots, wheel combinations, so this is going to be a little dry. This part here is as exciting as it's going to get. Now, before I go on, I will say that there are certain instances where this won't work. Like, if the wheel nuts are actually the thing that pilots the wheel, this won't work on that. If the CG is in the wrong place, this isn't going to work on that. But generally, for most wheels that most people have on cars today, yeah, you can balance them horizontally on a steel ball. And I'll show you the proof graphically of how that works. In the beginning, when I started this trip down tire mounting and tire balancing, I bought one of these Harbor Freight bubble balancer. 90 odd bucks I spent on it. It's now a paperweight in the shed. It has all kinds of problems. It had run out issues. The casting, the head of it is quite heavy. It doesn't show any signs of balancing, so that can throw it off. The bubble level was very insensitive. The support frame was terribly made. See, these two go in. That one missed completely. You had to force it together. It was just awful. It could not be trusted. It did not balance the wheels on our cars. At about 60 miles an hour, vibration set in. So I had to find something else. Okay, so horizontal balancing. I did have a vertical balancer. I won't go into that. What I want to know is there a low cost and reliable way to balance a wheel horizontally? I think there is, and I'm going to show you the proof. Here's a picture for a steel wheel. They have a formed pilot generally on them, radiuses on them. This is more like an alloy wheel with a chamfered bevel and a central pilot. I started with a glass ball 3 inches, and I've evolved into a 2.5 inch steel ball. The nice thing about the ball is it centers on these machined or these formed parts that the wheel is centered on when it's on the wheel hub. So you are guaranteed that the axis of the ball is aligned with the axis of the wheel. Very important. The other thing of importance is where the center of gravity of the wheel assembly is. For some vehicles it's above this center point, others it's below. Becomes very important. Okay, so here we are. This is off our XB, which has a steel wheel. It was stable when it was on the ball. Here's the Corolla alloy wheel that you saw in the beginning. It was not stable. I could not let go of it. It would literally fall right off. So obviously I had something wrong with the geometry, and it took me quite a while to figure out what to do about that. So what makes the wheel balance on the ball? This is the steel wheel that did balance. Got the ball in here. It has a point of contact on the base. And in this side is just the basics, all the names and geometry and stuff. This side, we've tipped the wheel. Okay, so it's tipped. What happens? The weight where the CG is applied from the wheel moves to the left of this vertical line where the point of contact is on the ball. That provides a moment in this direction that rights the wheel and tries to make it balance. So with a regular wheel, when you put it on, there'll be a certain amount of imbalance. You will be able to find that. It will be stable. This is the Corolla wheel doing the same thing, but this time it did not balance because the ball was too big. It had the CG above this center point of the ball, In this case, that moment where the weight is applied is now to the right of this vertical center line. That makes the wheel tip even further. So it's unstable in this geometry. Can the wheel be made stable? Well, yeah, you could use a smaller ball, or you could temporarily lower the CG of the wheel. This one is kind of impractical. If you're hanging weights off it, it just isn't going to work. So going with a smaller ball is the way I did it. So I went from the 80mm glass ball, 3+ inches diameter, to a 2.5 inch one. Looked at some of the math. Yes, that should work. It should get the CG just below the center point of the wheel, and it should be stable. Okay, so this is a list of the different vehicles that I've changed tires on. They all seem to have a different hub diameter, and the 2.5 inch is 63.5mm, and as you can see, 67, that's bigger than the ball. And the Silverado was 77.8, yeah, a lot bigger than the ball. So what we have are these things called Hub Centric Rings. That's what this is here. And it presses into the hub and gives you a smaller diameter that works with the 2.5 inch ball, so that the CG of the wheel doesn't get above that important center point of the ball. And one day I just put the balance stool out on the ground. I didn't bother to level it up. Put the balanced wheel on top of the ball, put it on top of the non-level base, and it tipped to one side. But I know that this wheel works, it's good, but it tipped to one side. So the question is, does the base have to be level? So what I'm doing here in this one is finding out geometrically how this all works. So if the base is now tipped, instead of just tipping the wheel, we tip the base to see if it's not, because it's not level. What happens? Well, the weight still goes through the CG. The point of contact is now shifted. So there's a moment that will tip the wheel. Now this is exaggerated quite a bit. What happens when the wheel tips is that CG starts to go back towards this reaction force line. And it's a bit too big on this picture. But it will reach some point of stability as long as this isn't tipped too much. But what it tells me is, yes, the base must be level. And you want to do everything you can to make the base level that you're going to put the ball on. So here is the setup I have. This is the stool that I'm using. I made it out of scraps of wood. And I've got a steel plate on top because steel on steel works best. It gives you very low friction. Got a 4-foot level. Here's the laser, and it projects an extremely level line. They are really good at that. And this stool has 3 bolts, or 3 screws. There are nuts underneath that will allow me to adjust that whole stool for level. So I do it in two positions, one this way, 190 degrees to this, and it works. So takeaways from this whole thing: the ball centers the wheel, unlike the Harbor Freight bubble balancer, which didn't. You have to level the base. There was no mention of that at all in the Harbor Freight documentation. And you've got to use a self-leveling laser, which is what that is. And then it's all going to work. So in closing, yes, balancing this wheel on the steel ball does work. There's a tollway in Oklahoma that has 85-mile-an-hour speed limit. We've been to that limit on both cars. No sign of vibration at all. We've done family and friends vehicles. No vibrations reported from them either. In fact, one of them was an improvement over work done by a certain tire installation company that's rather a big chain in this country. So it does work. It's worth a try. If you're doing it on the cheap, you can do it on the cheap, and it will work for you. Good luck.